Okay, so this brings us to 12.4, where we need to implement an area function of the polygon. So the area is called A here, and we see that if we denote the coordinates of each of the points of the polygon by x1 and y1, so x1 and y1 here, x2 and y2 here, x3 and y3 here, then we can actually compute the area using what we have here on the right hand side, where in the first term we take the x coordinate of the first point and multiply it with the y coordinate of the second point. And then we take the x coordinate of the second point and multiply it with the y coordinate of the third point, all the way up to x coordinate of the last point multiplied by the y coordinate of the first point. So that's kind of it's kind of like the x coordinates are in their original order if you keep track of it, but the y coordinates are what we are called what's called circularly shifted in index. So we start at 2 and then have 3 and then 4 and so on, and then we end up at n and then 1 here at the very end. So they're like circularly shifted. And then we can see that something similar happens here at the bottom, but here we just change the it's the same thing that happens up here. We just replaced y and x and y, sorry. So we can imagine that if we can implement what we have here, we can actually also quite easily implement what we have down here by just substituting x for y and vice versa. And then we have a little bit of a note, and this is making so maybe when you look at this, maybe your first approach would be to do this using some kind of for loop. That would probably be my first approach. But here we are sort of asked to do it using NumPy operations to do it really efficiently. So like you would do it in a computer game. I think my approach in this case might be to first do it with a for loop and then do it using NumPy and then compare the two in a little bit of a test and then use my NumPy implementation. But I just think I'll do it in a single shot using NumPy. And then the last comment is that this formula, I don't know, it's probably not obvious, but it actually depends on the order in which we specify the coordinates. So if we specify the coordinates clockwise or counterclockwise, and therefore we should actually compute the abs of the area when we return it. I'll get to that when it becomes relevant. But let's just focus on the formula and this first part. So we need to implement the function getArea, and we can see it should be 424 in this case. So we'll just get started. I'll put in the function here. We need self as the first argument and insert a number, so we can put in a breakpoint and call the function as an example down here. And I'll remove the plot call from before. Then when I hit the debugger, it stops at the breakpoint. Then I can go to the debug console and I can get the x and the y coordinates. Okay, so if you think about the formula, this is x1, this is x2, this is x3 and so on, and this is y1, y2, y3 and so on. So we need to multiply this y coordinate with this x coordinate plus this y coordinate with this multiplied with this x coordinate and so on. So if you could take this list here and take all of these elements without 12 and then just shift them one step to the left and multiply everything element-wise, that would work. And remember that it's quite easy for us to multiply things element-wise by just using the multiplication operator. This will multiply 12 with 24 and give us 288. We can just verify this really quickly if we don't trust our big table, as it's called in Danish. Okay, so basically this is an exercise to begin with on how we take all of these elements and shift them one step to the left. And to do that, there is a function in NumPy called np.roll. Why is it np.roll? Well, you just need to read the documentation or Google it or something like that in order to figure out that function exists, but it does. It should be no mystery that it probably requires y as the first input argument, and we want to shift it to the left, so it should be 16, 8, 4 and so on. The second argument, it gives an error right now. The second argument needs to be the amount of places we want to shift this array. So let's try to give it a 1 and see what happens. So we can see that in this case we went from this to this. And this is actually not completely correct, because this 12 got shifted to the right. We need to shift to the left. So we can do that by changing this to -1, and that'll actually do the trick. And we can see at the end of the array, this first number is appended to the end when we shift to the left, which is also what we want. Remember, we want this number to be multiplied by 4 eventually, so it's good that 12 is shifted to the last place. That is what happens in this last calculation here. Okay, so now that we got that, we just need to multiply it by the x coordinates, and then we need to sum everything, and we can do that using the sum function. So all of this should basically compute this first part of the exercise. Okay, so I'll take that and copy paste it in here, and then we need to subtract basically the same thing, but if you look at it a little bit carefully, you can see that it's the same thing if we change x with y. So we can just substitute x for y in this expression, and we should be done. And remember the minus, of course. So y instead of x, and x instead of y. And this should be 2 times the area. So it has the right magnitude. And then in order to get the area, we divide each side by 2. And now if I run it, we get the right magnitude, but it has a minus. And that is because it depends on which order we specify the points. Do we specify them in a clockwise or counterclockwise order? And the area should of course be invariant to that choice. So we need to return the absolute value. The absolute value is what we in mathematics write as this. And in Python we can do that using np.abs. That will compute the absolute value. So we can just return the absolute value like this. Okay, so I remove the breakpoint, I stop the debugger, I save the file, and then we can go to the tests, and we can see that now it seems to work. Okay, so congratulations, you made it all the way through all the ordinary exercises in this course. I think I'll just look at the last 2, but that was actually all of the normal exercises. So it has been a pleasure to guide you so far, and I really hope that all of you do super well at the exam. And also, of course, good luck with the last of the projects. So thanks for your attention.